The second challenge is to take this solar array on the roof of a conceptual building and change the angle so that it matches the latitude of Oakland, California, and then calculate for an entire year what the cumulative insolation value is on the surface of that panel. This is the second challenge. I'm trying to find out what the insolation values are on this surface over the course of an entire year for Oakland, California. So if I actually pick on this application, I just want you to see that the location relates to the location of the project, and 37.79 is the latitude. I'm going to get out of that. If I now, make sure I haven't selected anything, if I pick on the panel over here, I'm going to change this so it says, no, that's what happened before. Why did it do that? $37.79, and it's changed. Now I want to look at the analyze radiation. I'm interested in over the course of the year, so I'm going to pick multi-day, 1 year study. I've got my longitude latitude here. I'll do sunrise to sunset. I can go down as low as 1 hour values to calculate it, and I'll say OK. And now I'm ready to do the study, so I can say select mass object. I'm just picking on the surface there, and down here I've got my report as solar radiation default cumulative values over the period of the year. All I need to do is click on this, and there's my answer. 393102 British thermal units, or 393 MBTU. So here's the spreadsheet. Remember, the latitude for Oakland was 37.79 degrees. So the rule of thumb is that that's the angle to set your photovoltaic rack at to get most energy. But what's really exciting about this is if you look, you can actually see that you're not getting something symmetrical around that value. If I create several increments of 5 degrees, both sides of that latitude value, I can see that actually making the rack a little bit steeper results in more energy. So this is actually where I'm getting most energy on the surface of the photovoltaic rack. Now remember that the rack itself might be, the photovoltaic panels might be 8% efficient, or maybe at best 15% efficient, so you'd have to adjust how much energy you're actually getting. But just looking at what falls on the surface, that's pretty significant information. The rule of thumb gets you so far, but actually measured quantities get you towards a better solution.